Welcome to Study Loop.
In this question, we want to know how many polarization sheets is required to rotate a beam 90 degrees first, and then require how many sheets we require to have 60% of the original intensity at the same degree. We can do this rotation with only one polarization sheet because if we put 90 degrees directly, we will block everything. So for the first situation here, we can use two polarization sheets. So let the first one at the angle theta and the second one at 90 degrees. So how will be the intensity? So the intensity will be I0 cosine square of theta cosine square of 90 degrees minus theta. So we can write this as sine square. So I0 cosine square theta sine square theta. So provided that theta is not 0 or 90 degrees, we have the intensity is different from 0. And this means that let's pass it through and the polarization in the end will be 90 degrees. Now, for the second case, we want to know how many sheets is necessary to make the polarization 90 degrees and also have an final intensity of 60% of the initial intensity at least, I0. So consider n sheets, making an angle of theta degrees, that is theta is 90 degrees divided by n, relative to the direction of the polarization of the incident radiation. So the intensity in the end will be, after n sheets, will be I0 cosine of 2n of 90 degrees divided by n. And we want to know what is the smallest value of n for which this is greater or equal to 0.6 I0. So this means that we want to know cosine of 2n of 90 degrees divided by n greater or equal to 0.6. So we can try each value. So let's try it out. So n increases as an integer. So let's do it for n equals 1. This is cosine square of 90 degrees. This is 0. N equals 2. This is cosine to the 4th of 45 degrees. This is 0.25. N equals 3. This is cosine over 6 of 30 degrees. This is 0.422. N equals 4. Cosine to the 8, and angle 20.5 degrees. This is 0.51. We are getting close. N equals 5. Cosine to the 10th of 18 degrees. This is 0.605. This is greater or equal of 0.6. So we just need n equals 5 sheets of polarization, making the angle between them theta 9 degrees divided by n, so 18 degrees.